Alright guys, welcome to NC Math 4. Today is 7/21 and we're going to take a look at solving quadratics by factoring. So solving quadratics by factoring. Okay. You've seen this before, so this should be a review topic. It should be pretty straightforward. This hinges upon the idea of what's called the zero product property. Now what the zero product property says, if A times B equals 0, then what must be true? Well, if A times B equals 0, then A equals 0 or B equals 0. So that is the zero product property. Alright, so when we use this in factor, we're going to break it down to two multiples, two factors that are set equal to 0, and then we're going to use that to find a solution. So key point here, the equation has to equal 0 to start. Alright. Now there's a bunch of patterns that we already know that we've learned previously, so I'm just going to run through these patterns. You're going to have to solve some of these tonight. Alright, let's start with number 1, so it'll be pretty easy. Okay, this is called a difference of squares. Now the way the difference of square patterns works is if you have a squared minus b squared, has to be a minus sign, this will always factor to a minus b, a plus b. Okay? So that's the difference of squares pattern. If we take a look at an example, we have something like x squared equals 16. Okay? Now remember, we're going to use the zero product property, so the first thing I have to do is make this equation equal 0. I usually want my highest degree term to be positive, so I'm going to subtract 16 from each side. So I subtract 16, I get x squared minus 16 equals 0. Now I can factor the left-hand side. So if I factor the left-hand side, I'll get x minus 4, x plus 4 equals 0. So this says a times b equals 0. So either this is 0 or this is 0. So what number can I plug in here for x to make x minus 4 equal 0? Well, if you're not sure, you can do that work off to the side. X minus 4 equals 0 and x plus 4 equals 0. Now I'll go ahead, for this one I'll add 4 to each side. And I get x equals 4. Over here I'll subtract 4 from each side. And I get x equals negative 4. So those are my answers. I'm going to put them in what's called a solution set. So I'm going to put x equals, I'm going to open up a set for set notation, 4, comma, negative 4. And there's my answer. So that's factoring a difference of squares. Okay. Next one, we're going to take a look here. We're going to go ahead and take a look at what happens when we have a trinomial with a equals 1. So specifically, what this will look like is you'll have something like x squared plus bx plus c. And what we're looking for here are two numbers that multiply to give me c, but add up to b. Okay, so we've seen this before. We did timed quizzes if you were in my class previously. All right, so here we're going to take a quick look. We'll start with a pretty easy one. Let's just go ahead and go with 3x squared plus 21x plus 30 equals 0. Now this one already equals 0, so I don't have to move anything around, but there is something new here. All right. Now this says a equals 1. A is the number in front of x squared. Is that a 1? No. That's because we have a GCF in this problem. So you'll see here 3, 21, and 30 are all divisible by 3. Now I'm going to factor it out and then divide. You guys are pretty smart, so you'll probably be able to just divide by it. Okay, but I'm going to factor it out, so I get 3 times x squared plus 7x plus 10 equals 0. All right. Now here you can see this 3 out front and this 0. If I want to get rid of this 3, I can divide each side by 3. Because we all know 0 divided by anything will always give us 0. Okay. Sorry, it should be a 7. My apologies. So now, like we said before, I'm looking for two numbers that multiply to give me C, but add up to B. So what two numbers multiply to give me 10, but add up to 7? And you're going to have to do a little guess and check here, right? But here, we're going to end up with x plus 2 and x plus 5 equals 0. And now, again, I can set these both equal to 0, but I think you got that pretty well last time. If x plus 2 equals 0, then x equals negative 2. If x plus 5 equals 0, I'll subtract 5 from each side, and x equals negative 5. So there's my set of numbers that make that equation true. Okay, so that's when a equals 1. All right. There's another case where a is greater than 1. This is the jump the cow method. We're going to go ahead and spend some time with that on Friday. For now, I just want to get the easy ones down. Okay, so that's the jump the cow method. So again, we saw difference of squares. We saw a equals 1. We're going to take a quick look at what's called a sum or difference of cubes. Okay, so the next one is the sum and difference of cubes. Okay, so this is actually two patterns. Some people teach it as two patterns. I don't. I actually just teach it as one pattern, but I'll show you both of them, right? So if we have here a cubed minus b cubed, that is a difference of two cubes. Likewise, we have a cubed plus b cubed. That is a sum of two cubes. So to factor this one, right, I know this pattern is always going to end up with a binomial, which will be a minus b, and then a trinomial. Now the trinomial looks a little weird, right? It's going to go ahead and be a squared plus ab plus b squared. Okay. This one over here, first binomial is going to be a plus b. Right? And then the trinomial this time is going to be a squared minus ab plus b squared. Okay. Now, the way I teach this traditionally is I talk to students about SOAP. Okay. This sign is always the same. This sign is always the opposite. And this sign is always plus. So SOAP. Okay. So here you can see this is the same as that one. This one's the opposite of that one. And this one's always plus. Same thing here. This one's the same as that one. This one's the opposite of that one. And this one's always plus. So the one trick you can use is SOAP to fill out your signs before you do the rest. Okay. The second part I teach is taps, right? So here I always take the cube root of the first one and the cube root of the second one. And then I tap. I always tap left, left, a squared. Left, right, ab. Right, right, b squared. So you can see over here, a squared, ab, b squared. So taps will work, okay? So that's how we factor a sum or difference of cubes. Now, how do we solve them when they come up, okay? So let's say we've got one like, oh, I don't know, example here. We'll go with a nice 3x cubed equals 375, okay? So first, right, we're using the zero product property. So the first thing I have to do is I have to set this equal to 0, okay? So I'm going to subtract 375 from each side. Okay. When I do that, I'm going to end up with 3x cubed minus 375 equals 0. Now, as we learned last time, I can look for a GCF and I can factor it out, or I can just divide by it. If I look at these numbers, 3 and 375, both look like they're divisible by 3. So I'm going to divide them both by 3. Whatever I do to one side, I do to the other. 3x cubed divided by 3 is x cubed. 375 divided by 3 is 125. Equals 0. Now here I can see this is a difference of two perfect cubes. Because this is x times x times x, so 3x's. And this is 5 times 5 times 5, so this is 25. So I'm going to go ahead and set up my pattern. I know there's going to be a binomial. I know there's going to be a trinomial. And equals 0. So first I'll fill in my signs. This one's going to be the same. This one's going to be the opposite. And this one's always plus. Now the cube root of x cubed is x. The cube root of 125 is 5. And now I'll do my taps. X squared. 5x. 25. Okay. Now, if we were to continue to solve this one, we would go ahead and say, well, x equals, what makes x minus 5 equal 0? Well, I would add 5 to each side, and I would get x equals 5. Now, for this trinomial, we're going to need another technique to solve this that I'm not reviewing yet, so we're just going to go ahead and leave it at dot, dot, dot. We're going to find that there are 3 more solutions to that. Okay? All right, so the last pattern we're going to take a look at today is what's called factoring by grouping. Okay? So here, by grouping. Okay. Now, so far we've seen 2 binomial patterns, difference of square, some difference of cubes, and we've seen 1 trinomial pattern where a equals 1. We're going to take a look at now what happens when there's 4 terms. Okay, so a four-nomial. So here, we'll go ahead, we'll make one up. We'll say something like, I don't know, x cubed plus 4x squared equals 3x plus 12. All right. Now again, I could look for a GCF here and see if there's something they're all divisible by. But remember, the first rule is I have to get it to equal 0. I want my highest degree polynomial to be positive, so I'm going to move these over there. As I move them over, their signs are going to change, right? So there's just another way to look at something we've already seen, right? So I get here x cubed plus 4x squared. This 3x moved over, so now it's minus 3x. This 12 moved over, so now it's minus 12 equals 0. And that's because to move them, we subtract 3x from each side, and we subtract 12 from each side. Okay. Now here, there's 4 terms. So first thing I do, I look for a GCF. Is there a GCF? No. Okay, so what I'm going to do is I'm going to group the first 2. I'm going to group the second 2. All right. Now here, this happens sometimes, and I made sure it happened on this one. See here how I trapped a negative sign out here? If you trap a negative sign out here, you need to change that sign right there. Okay? If that had been a positive sign, I would have left it alone. But because I trapped a negative, I have to change the sign right here. Now I'm going to go ahead and factor. I'm going to look for the GCF of these 2. So what's the largest thing that goes into x cubed and 4x squared? Well, it looks like x squared. When I factor that out, I'll be left with x plus 4. Over here, minus. Now, what goes into 3x and goes into 12? 3. And I'm left with x plus 4. All right. So here, we did the GCF twice, right? GCF for these 2, GCF for these 2. Now look what happens here. I have an x plus 4, and I have an x plus 4. So that becomes a common factor that I can pull out front. Okay? So what I'm going to do is I'm going to go ahead and write x plus 4 times whatever's left over. Well, what's left over? X squared minus 3. Perfect. All right, now I've got 2 binomials. Real quick, I'm going to check this one because it's degree 2. Is this a difference of 2 perfect squares? Well, I guess I could do it that way, right? So I'm going to keep factoring this one. I'm going to bring down the x plus 4. And then here, this x squared minus 3. I'm going to make it x minus the square root of 3 and x plus the square root of 3. 0. Okay. So now I can write my solution set. X equals negative 4, makes that one equal 0. Positive square root of 3 makes that one equal 0. And negative square root of 3 makes that one equal 0. You can see this solution set contains 3 answers. All right. So that's a quick review of factoring. I'm going to ask you guys to practice that tonight. There's only 8 problems. Go ahead and solve them and submit them to Canvas. And we'll tackle Jump the Cow on Thursday, whenever I see you next. Ta-ta.